Hi, today I would like to talk to you about the second of the solid principles, Open Close Principle or OCP, and how it shapes the architecture of software systems. The OCP was first introduced by Bertrand Meyer back in 1988. This principle says that a software artifact should be open for extension but closed for modification. In other words, the behavior of a software artifact should be extendable without having to modify that artifact itself. This principle is at the heart of what we strive for as software architects. After all, if simple changes to the requirements force massive changes to the underlying software, then we have failed in our job as architects. The goal is to create systems that are flexible and adaptable and are able to accommodate new features and requirements without extensive rework. Let's consider a thought experiment to illustrate the importance of the OCP. Imagine we have a system that displays a student's performance on a web page. The data is scrollable and bad grades are rendered in red. Now the stakeholders come to us and say they want the same information turned into a printed report. The report should be properly paginated with appropriate page headers and footers and also column labels. Oh, and they want the bad grades to be marked with an asterisk instead of rendered in red. Clearly, some new code needs to be written to accommodate this change. But the key question is, how much of the existing code will need to be modified? A good software architecture, one that adheres to the OCP, should minimize the amount of old code that needs to change. So how do we accomplish this? We start by applying the single responsibility principle or SRP. By separating the responsibilities of calculating the reported student data and presenting that data in different formats, we can create a data flow view with an analysis procedure and two reporter processes. Next, we partition these processes into classes and separate those classes into components. This allows us to organize the dependencies between these components in a very specific way. We want to create a hierarchy of components with the higher level components protected from changes in the lower level components. In our example, we have the controller at the top left, the interactor at the top right, the database at the bottom right, and the presenters and views at the bottom left. Classes marked with I are interfaces and those marked with DS are data structures. The dependencies between these components flow in a single direction, with open arrowheads representing using relationships and closed arrowheads representing implements or inheritance relationships. The key point here is that all the dependencies are source code dependencies. An arrow pointing from class A to class B means that the code of class A references the name of class B, but class B does not references class A. This one-way directional control ensures that higher level components don't depend on lower level components, which would make them vulnerable to change. At the top of this hierarchy, we have the interactor component. This is where the core business rules reside, the highest level policies of the application. It is the most protected component insulated from changes in the controller, presenters, views, and even the database. Changes to any of those lower level components should have no impact on the interactor. All the other components are dealing with peripheral concerns while the interactor deals with the central concern. By keeping the interactor isolated from the changes in the lower level components, we adhere to the open-close principle. So there are two important benefits we achieve by applying the OCP. The first one is the directional control, which allows us to protect the higher level components from not being subject to modification due to changes in the lower level components. We do this by creating interfaces to inverse the dependency relationships between higher level components and lower level components. For instance, student data gateway interface between the student report generator and the student data mapper exists to invert the dependency that would otherwise have pointed from the interactor component to the database component. The same is true of the student report presenter interface and the two view interfaces. The second one is the information hiding, which is served by the student report request interface. It is there to protect the student report controller from knowing too much about the internals of the interactor. If that interface were not there, then the controller would have transitive dependencies on the student entities. Transitive dependencies are a violation of the general principle that software entities should not depend on things they don't directly use. So even though our first priority is to protect the interactor from changes to the controller, we also want to protect the controller from changes to the interactor by hiding the internals of the interactor. In closing, the OCP is a foundational principle that shapes the way we design and structure our software systems. By partitioning functionality, managing dependencies, and protecting higher level components, we create architectures that are open for extension and closed for modification. It's a principle that has stood the test of time and one that will continue to guide us as we build the software of the future. Thank you.